Hello, everyone, and welcome to The Current, the North Central Region Water Network's Speed Networking webinar series. The network is led by University Extension in 12 upper Midwestern states, the ones that you see in that little map at the lower right-hand corner of our first slide. My name is Rebecca Power, and I will be moderating the session today. Today we're going to be talking about manure, water, and soil health. A great mix of things. And before we introduce our presenters, a few notes to you all about the way these sessions work. So you can see the way that we do questions. We ask you to submit your questions for presenters in the chat box, and you can find the chat box in the purple Collaborate panel in the lower right-hand corner of your screen. And if you click on that purple panel, there's an icon with a little chat icon with a speech bubble there. So that's how you submit your questions. We will compile all those questions and put them in some sort of reasonable order for our presenters. So we'll get to that. We should have a good amount of time for questions at the end. If you're having audio issues, there is a phone option that can be accessed by opening the session menu in the upper left-hand area of the webinar screen. And there's an option to select Use Your Phone for Audio. We do record all of these sessions and make them available either at northcentralwater.org or learn.eextension.org or both of those areas. So if you would like to access the information later, or if you would like to share the information with someone that wasn't able to attend today, you can do that. Our presenters today are Amy Schmidt and Linda Schott from the University of Nebraska-Lincoln, and they are going to be talking about short and long-term effects of manure and biosolids on soil quality. Tang Lim from the University of Missouri Extension will be helping us answer the question, can manure affect soil health? And then Steve Safferman and Jason Smith from Michigan State University will be talking about the fate of winter applied nutrients as it relates to water quality particularly. And then finally, Leslie Johnson from the University of Nebraska is also, she's going to be talking to us about next steps for North Central Region soil health teams, or groups of extension professionals and others that are addressing soil health across the North Central region. Okay, let's go ahead and get started. So here's Amy Schmidt, picture of Amy, and a picture of Linda Schott, and a little bit more about them. I'm not going to read those in detail, just let you have a few minutes to take a look at where they're coming from professionally, and we'll go ahead and get started with their presentation. So thanks, Amy and Linda.
All right, thank you, Rebecca. So this is Amy. I'm very happy to be a contributor to the information that's going to be shared in this first presentation this afternoon, but my role here is just going to be to introduce Linda, who is my graduate student, and she will be presenting. Linda is a doctoral student in biological systems engineering at the University of Nebraska, and the information she's presenting this afternoon is the result of an extensive review of literature that she conducted recently, looking at data from short and long-term studies reporting on changes in soil characteristics under manure and biosolids applications. So I'm going to turn things over to Linda and let her get started with the presentation.
Thank you for the introduction. My name is Linda Schott, and the objectives of our literature review were twofold. One, to summarize the results of short and long-term studies reporting effects of livestock manure and municipal biosolids on soil physical, chemical, and biological properties, in addition to indirect indicators of soil health, and we included climate resilience, crop yield and quality, and things like that. And then the second objective was to describe future research needs related to manure and soil health. And so in order to do this literature review, I primarily used the Web of Science to search for the following keywords and variations that are included in this table. And they were associated with crop performance, soil properties, and climate resilience. And only papers that had manure as the varied factor were considered. Initially, we identified about 220 peer-reviewed papers, but only 160 were deemed relevant. And this is because some of the papers focusing on organic versus conventional systems could not be included because the cropping system and cover crop use in these systems generally differed. In addition, we also found 115 review articles about manure or municipal biosolid effect on soil properties. I'm seeing a bunch of notices.
Yeah, Janice, are you seeing those? So thanks, Linda. We'll just pause just a minute. So a couple people seem to be having issues with the visuals. I am currently seeing them, and my guess is that Janice is too because she hasn't said anything.
That is correct, yes. I'm trying to figure out what's going on in the background, so.
Okay, great. So Shelby and Jill and David, we got it. And Janice is gonna see if we can help. Tang, did that rejoining the session make a difference for you? Can you see the slides at this point?
No, no slide, only briefly though. Can you hear me?
Yes.
Yeah, so when I rejoin, I did see, now I have seen it just flash. Now I can see it. It's good.
Great. Okay, it looks like we've got the pretty much solved. Perfect. Great. Not sure what that was, but we're glad you can see them. And go ahead, Linda.
Okay. So as you can, this table just shows the number of peer-reviewed articles that we identified that discuss the effect of manure or biosolids on the soil properties listed on the left-hand side. As you can see, chemical and physical properties have been very well documented in the literature, and there have been a number of literature reviews focused on those metrics, but not much research has been done on soil biology and how it's affected by manure application. In the 66 articles that we identified, there are 8 biological properties, and most of them focused on microbial biomass carbon, which is a measure of abundance of soil biology. And there weren't many other metrics that were investigated in these. So there really weren't that many that looked at nitrogen mineralization or nematodes or earthworms or things like that. Because there were so many papers that we identified, we ultimately decided not to summarize yield data within this literature review, but we did generate a list of all the references that we found of the papers reporting yield so that if someone else wanted to utilize those, they could. Additionally, we identified 12 papers of the 160 that looked at soil health metrics, which just meant they had soil physical, chemical, and biological properties, but they weren't packaged to be about soil health per se. They just included those metrics. And so we just wanted to share some results of the literature review. And these are very broad strokes because the effect of manure and biosolids on soil properties is dependent on the amendment and the soil itself. And so for soil chemical properties, we found that manure and biosolid application increased soil organic carbon, nitrogen, phosphorus, potassium, and soil micronutrients, but it had a mixed effect on soil pH and cation exchange capacity. And in general, the effect of manure and biosolids on soil chemical properties is heavily dependent upon the chemical properties of the amendment and the initial chemical properties of the soil. Many of the studies that we found also did not apply equal amounts of nutrients when they were comparing the effect of inorganic fertilizers to organic ones. And many applied manure at a nitrogen rate annually, which generally leads to the over-application of phosphorus and can become an environmental risk for water quality. For soil physical properties, again, in broad strokes, we found that application of manure and biosolids increased aggregate stability and infiltration, but decreased bulk density and compactability. But there were mixed results on whether or not manure application increased or decreased water holding capacity or compaction. So for soil biological properties, microbial biomass carbon, microbial biomass nitrogen, respiration of the microbes, earthworm abundance, and nematode abundance were all increased with manure or biosolid application. But microbial diversity, often measured with phospholipid fatty acids, and the abundance of microarthropods were not generally increased with manure application. So the second objective of this literature review was to provide recommendations for future research. And our first recommendation is to incorporate quantification of soil biological metrics in addition to reporting the effects of manure on soil physical and chemical properties, since soil biology provides ecosystem services like nutrient cycling, and they're important to soil health in general. Our second recommendation is to investigate the short and long-term effects of a single application of manure or biosolids to support an effort to identify the optimum frequency of application for improving soil health. And our third recommendation was that studies should be designed so that nutrient application among treatments is balanced on an annual or multi-year basis so that the effect of manure can be better compared to inorganic fertilizers. And finally, these studies should also provide a discussion that clearly relates research findings to management decisions that are relevant to agricultural crop producers that are actually going to be using manure to improve their soil health. And we just wanted to thank the Soil Health Institute and the North Central Region Water Network for the funding for this project, and also to thank the undergraduate student workers, Mara Zelt and Ashley Schmidt, for their help with identifying and organizing articles.
Great, thank you, Amy and Linda. And again, just a reminder for folks to put any questions that you have for Linda and Amy in the chat box, and we'll, like I said, we'll harvest those and get them to the presenters after all of our presenters are done. And thanks to all of you that are working with those funky blank out of your screen. We haven't had that happen before, so not sure exactly what's going on. But thanks for bearing. There may be a bandwidth issue, but thanks for bearing with us. And we will go on to our next presenters. So I'm gonna sneak through these here again to get to the conclusions. Okay. Next, hopefully Tang, it looks like your slides might be blank, so we'll see if that's still the case and introduce you. So again, Tang Lim is Associate Professor at the University Missouri Extension. I'll let you read a little bit about his background there. And Tang, can you see your slide screen at this point?
No, not really. But I do have a backup, the same slides in my computer, so I'm just going to be looking at that and present. So I'll tell you when to, well, you can tell when to advance the slides for me. How's that?
Okay, sounds good. So I'll go ahead and just advance to your first slide right now.
Okay, so hi everyone, this is Tang from Missouri. Just want to acknowledge the co-authors on this, we have Mr. Alan Wang, and then also Dr. Brent, Sarah Sorania, and also Randy Miles. The last three were from the University of Missouri Soil Health Lab. So the reason that we're looking at this today is that we were tapping into a rather unique cover crop cost share program offered by our Missouri Department of Natural Resources. So this particular set of samples that it's part of the 1,700 samples that belong to the 2016 and 17 soil samples that were collected throughout the state of Missouri. So we thought that this is a pretty unique program and an opportunity to present the systematic evaluation of the soil health pertaining to the cover crop and also the manure applications. But because of the time frame, we were only focusing on the manure because we're hoping to be able to do more in the short future. Next. So this slide is basically looking at the number of samples that were collected in the 16-17 cover crop cross-share program, and you can see a wide range of different number of samples collected throughout the different counties. Next. So some of the key soil health indicators or variables that we included in this report, ranging from some of the more traditional organic carbon and phosphorus and nitrogen, but even the nitrogen, it's rather unique because we were looking at the potentially mineralizable nitrogen here. So more indicated than just the nitrogen, regular nitrogen, and of course, we also have the bulk density, which is a key factor that has direct impact on the yield, the crop yield, and also a very unique one that I like a lot is the water stable aggregate that indicates how much the ability that the soil holds itself together, and that has direct impact on some of the very important environmental impacts such as the erosions and holding the water and nutrients together. So next slide, please. So the additional research plot data, well, we like to have a little bit of backup plan because we're dealing with a pretty unique set of data, and I was afraid that we could get into some issues not knowing what we're doing. So we were planning on also to be looking at what we call a sandbound field, which is right here on the University of Missouri campus. That was established in late 1800. It's basically looking at the different variety of treatments ranging from full fertility, specific to the nitrogen, phosphorus, and also some manure uses, and even green manure, which is basically red clover, and also no fertility. So this is another unique set of data that when we're looking at correlating the manure and the soil health together. So going back to the statewide samples, because of the time frame, we were only focusing on the 1,000 samples that we had on hand during that time. So for the 1,000 samples, they were collected from the 71 counties. Specifically, there were only 78 of them that had applied the manure onto the fields. So we have 922 that did not have any manure application. Next slide. So the statewide soils results indicated here, unfortunately, statistically speaking, there was not much of a difference when you compare the soil with the manure versus the soil without manure. And unfortunately, again, one parameter that really stands out is the phosphorus. So that's the only one that really showed a significant difference. So it was rather unique, and then some of the values seem confounding too. But of course, we realized that this set of data is collected from all the corners of the state and presenting a lot of different soil types and different practices, different crop grounds, and different manure uses too. So it's something not usual, but it's not something that we did not expect of. Next slide. So when we compare only on the county level, so we handpick the top 3 counties that had the most manure sample apply. So you can see that here the Pettis, Monotol, and also Stoddard County especially the started county. It's a very unique one that the within county comparisons did allow us to have compare the more homogeneous between the smaller region and similar soil. So you can see the different variables listing here. Some of them are clearly showing the statistical difference, especially on the organic carbon, active carbon, the phosphorus, the nitrogen, particularly the water-stable aggregates, especially the started county. So next slide. So based on the comparison of the county in general, the manure did increase the soil carbon. And also, unfortunately, in general, the phosphorus values were clearly affected by the manure application. For started county, which is known for its sandy soil, the manure clearly increased quite a few important indicators. So this basically confirmed that the sandy soil contained less nutrients and the impact of manure was clearly observed. Next slide. So here are some of the graphics showing the both the statewide samples and the Sanborn field, which is our research plot samples, comparing the overall on the left, soil with manure and soil without manure as a state, and then the figure on the right is basically the full fertility, manure only, and no fertilizer. So for this particular plot, it's showing the organic carbon. As you can see that we didn't see as clear of a trend when it comes to the statewide, but clearly there is the indicative evidence that the research plot showed that the manure application has an impact. The next slide, it's basically the same comparisons, except that this one is showing the water-stable aggregates. So the next slide, which is the take-home messages, what we did based on this 1,000 sample was that there was no significant difference for most of the statewide fields with and without the manure applications, except for the phosphorus. And then when we dive down into the county level, the manure did increase quite a few important soil health indicators such as the carbons, and also for one particular county, it's very clearly shown that the manure application increased the organic carbon phosphorus, the PNN, the nitrogen, and also water-stable aggregate. Data set for the control experiment plots, which is the Sanborn field, also shows the similar findings from the county levels data, that the manure applications has resulted in higher soil, organic carbon, and many other variables. So we expect to be able to continue more data analysis on the 16, 17, and 18 data set, hopefully to find more interesting results from there. Want to acknowledge the fundings that we have received and also the Soil Health Institute. So here's our context. Thank you.
Thank you, Tang, and thanks for doing that on the fly without being able to see your slides. Are you able to see them yet at this point, or?
Nope.
Not yet. Okay. Well, our apologies again. We're not sure exactly what's happening for some of you, but thanks again so much for those of you that are bearing with us here. And it looks like it's not an issue for everybody, but for a substantial number of people. That said, let's go to Steve Safferman and Jason Smith. So they are at Michigan State University and are going to be talking to, and just you can again see their background there, working as a team, and they're going to be talking about fate of winter applied nutrients. So thank you, Jason and Steve.
Well, thank you, Rebecca. We appreciate this opportunity to participate in this webinar. I'm going to ask Jason Smith to provide the presentation, as he's been working on this for several years as part of his PhD program. And so this represents a part of that program, and we appreciate the funding from the Water Network as well as the Soil Health Institute. So Jason, if you'd like to go ahead.
All right, thank you very much. Again, I'd like to start off by reiterating thanks for the funding. It's allowed us to generate a number of documents that we hope will be useful to industry and academics alike. And all of these documents are currently available online, I'd like to say as well. The first document is a journal-style literature review of the topic, detailing findings of laboratory activities, field studies, as well as an assessment of the current state of related policies. For this document, we've also derived a Cliff Note style fact sheet for those of you who might be a little bit short on time, as well as a table of document summaries that provides a 100-word summary and a bulleted list of key facts presented in the articles for the literature review. Finally, we've also generated a white paper style document outlining what we see as key research needs based on the literature reviewed. Obviously, in the brief time we have here today, and I emphasize brief, I'm getting eyeballs from my primary investigator over here. I won't be able to have the time to cover everything presented in the papers, but I'm going to do my best to hit highlights, and I hope you'll take the opportunity to review the documents in your own time. So let's start at the beginning. What do we mean when we say manure application? As with many things we'll discuss today, that definition can depend on where you're located. The generally accepted definition is the application of animal manure to snowy or frozen agricultural land. Depending on your state, this definition can also include application dates, as well as specifications on depth of frozen soil or even snow depth. Historically speaking, this was once considered a safe and in many ways preferable practice. From a management standpoint, for instance, there are fewer physical barriers to winter application, and so was preferable from that standpoint. However, as communities have become more environmentally minded, the potential downfalls became more clear, primarily the increased potential for runoff during flash thaw events, and today management standards are guided by MPDES permitting, but ultimately are individualized state by state. So although the risk of runoff is clear, trying to assess the risk and the quantity of nutrient losses can be extraordinarily complex. And it depends on a number of different factors, many of which we've listed here. Isolating the effect of even one of these variables in studies, however, can be very tricky, and assessing their interaction can be even trickier still. As such, a lot of the influences of the combinations of these factors is at present poorly understood. So with this level of complexity, how do we deal with that? Usually in one of two ways. A lot of states have either instituted or are in the process of instituting outright bans on winter manure application. All things being equal, this is probably the easiest route, but allowances need to be made for extenuating circumstances and emergency spreading of manures onto frozen ground. These allowances and the fact that emergencies normally take place during later winter when thaws are more imminent have led to some criticism of this method. The only other real alternative is to allow winter spreading, but with best management practice guidelines and restrictions. These generally relate to application timing, rate, and setbacks, as well as manure and field characteristics such as manure solids, field slope, and field cover. As these characteristics are critical to both methods, we've focused the literature review on case studies and laboratory studies that have attempted to look at these issues. Probably one of the most studied parameters is application timing. With respect to time, researchers have generally looked at three questions. First, is it better to apply in winter, fall, or spring? Secondly, does proximity of application time to thaw time actually matter? And third, does it matter if application occurs before, after, or in between snowfalls? This is also probably one of the areas that has the most agreement amongst literature sources. With regard to field nutrient retention, it's been found to be generally true that spring and fall applications are preferable to winter applications. No surprise there. Studies have shown anywhere from 2 to 8-fold increases in nutrient losses, and this pattern is held true even on fields that have relatively gentle slopes. It's also been shown that if winter application must be performed, earlier winter is preferable for nutrient retention, and applications within 2 weeks of thaw events have been shown to be particularly catastrophic as far as nutrient releases into local water bodies go. There are, however, a few outlier studies that have noted certain benefits of winter manure application from a soil health perspective. Young and Holt and Young and Muchler early on produced field studies that have shown dairy manure application reduced sediment loss and thus total nutrient runoff for certain fields. However, this was attributed to those fields having relatively large slopes and no other erosion control practices. It's also been noted by several studies that covering manure with snow has slowed ammonia volatilization. But the downside of that is that the ammonia in a lot of these studies has largely been lost in runoff rather than working its way into the soil matrix. One of the BMPs gaining a lot of attention recently has been the use of residues and cover crops as a mitigating factor for bulk manure loss during thaw events. The theory behind their use as a BMP is that the presence of residue and cover crops will slow the velocity of runoff from spring thaws, allowing for a reduction in particulate loss, and any live crop may also help to incorporate soluble nutrients into plant biomass. You may have noticed in the policy slide that several states that had requirements for BMPs included field cover crop in winter application, any sort of winter application that was going to be performed. However, several studies have noted that there may be drawbacks to this best management practice, and that's a current big topic in the literature. Firstly, for live cover crops, dormancy obviously negates uptake of nutrients for large amounts of the thaw period. Other studies have also noted that exposure of live cover crops to freeze thaw events has produced an increase in releases of soluble phosphorus at field edge, presumably due to the lysing of plant cells. Field cover, also particularly taller field cover, has been shown to act as a catchment for snow in certain instances, and that can increase overall runoff volume and thus increase overall risk. Several studies have also noted that plant presence actually increases the duration of soil impermeability during thaw events. Again, this could potentially increase the risk of nutrient loss during flash events. A quick mention on a few other factors that have been mentioned in policy but have relatively literal literature. Predominantly, we're talking here about setbacks and slope. With regard to setbacks, we couldn't find much literature regarding a comparative study of setback distances aimed at determining appropriate values. And this has been reflected in policy, with a lot of states seemingly setting values based on expert experience, and states have a relatively high degree of variation in their setback preferences. Likewise, there's been relatively little literature on comparative slope analysis for winter manure application of manure, and states have similarly variable restrictions on appropriate slope. I provided just a few examples from Great Lakes states here and their variation. If you can actually see, it looks like the slides might have cut that off slightly, but it's, fear not, it's in the final documents. One of the ways to address, oh, sorry, pardon me, I forgot to make one last point. The reason for the lack of literature may be due to the presumed triviality of the findings, or perhaps due to the difficulty associated with normalizing field results for this type of data. One way to address that particular issue and any of the issues associated with the difficulties of working with variable field case studies would be through computer simulation. While several studies have attempted to account for wintry conditions while looking at year-round data, we found relatively few that use computer simulations to explicitly look at variations in winter manure application BMP parameters. One of the few was a recent article by Vedas, which looked again at the issue of manure application timing. The results largely echoed those presented in earlier case studies that we presented. Of particular interest is the finding that, again, late winter months are particularly hazardous to nutrient loss. At this point, I'd like to very briefly bring up my research group's own attempts to address similar issues as far as isolating some of the variables of interest, this time instead of in modeling in laboratory settings. One study we've looked at is the area of winter manure application timing, again, with respect to manure placement using box studies in a controlled laboratory environment. Our results again echo the field study findings that earlier winter applications result in greater nutrient retention, though we hope through variable isolation that we can produce data that will be meaningful in developing future empirical models. We've also attempted to further the work of cover crop analysis by looking at the effect of cover crop maturity on nutrient leaching. Again, our preliminary results on ryegrass have shown that older crops release roughly 20% less soluble phosphorus than younger crops do. Though these results are preliminary for both studies, frankly, and we're still in the process of conducting further testing. This brings me to the final issue of research needs. As we've kind of gone through already, further field studies to understand the relative benefit of BMPs under varying conditions are always helpful just because of the preponderance of different variables that we're constantly looking at. In particular, getting some finalization on the issue of setbacks would be very nice. Also, one of the issues that we noticed is that a lot of these don't necessarily take into account total mass balance for the timing strategies. Also looking at case studies on impact of policy changes. Here, what we're talking about is the fact that there have been a number of policy changes over the years, and it would be very nice to be able to have some sort of tracking of environmental changes that have been seen since ban implementation, something that would help us achieve a more adaptive management type strategy. Also, research on the persistence and movement of emerging pollutants, something that we didn't cover as much during the presentation today, but with increased focus on things like antibiotic resistance, pharmaceuticals, how these things relate to the winter manure application issue is also of great concern, as well as emerging issues of climate change and its effect on this issue, and of course the ever-present shift towards more industrialized agriculture and how that's going to affect management strategies. Thank you very much for your time. I'd also like to take this opportunity to thank Dr. Safferman and my undergraduate research assistant, Rochelle Crow, who was very much responsible for helping me aggregate a number of these different articles.
Thank you, Jason, and thank you, Steve. And just a reminder to our participants, everybody on the line here, to go ahead and put questions for presenters in the chat box. And now, last but not least, Leslie Johnson, who is a research technologist at the University of Nebraska-Lincoln. And again, you can peruse through the wealth of experience she brings to this issue here on this slide. And she will be talking to us about next steps for the North Central Soil Health teams. Thank you, Leslie.
All right, is everybody hearing me okay?
Yes.
All right, I had to go out and come back in, so I wanted to make sure. All right, so I want to thank the last three presenters. They demonstrated the exemplary strength that our soil team actually already has. So I'm going to turn the conversation just a bit and tell you where we plan to go from here. First, a little background. A couple of years ago, the North Central Region Water Network funded 2 seed projects that were related to soil health. One was more general in gathering soil health resources with a central core to become the go-to place for soil health information. And the other focused on how manure and soil health are related, and that particular side of it is where these mini grants came from that developed these literature reviews that you just heard about. So the two soil health projects overlapped often, and as their seed projects came to an end, the opportunity presented itself to merge the two teams and just be one Soil Health Nexus team. Excuse me, my phone keeps ringing. So we would be, what's that?
I said you're in demand, that's okay.
I guess, of course, when the presentation starts, that's when it rings. So we had the opportunity to become just one Soil Health Nexus team, and that opportunity allowed us to apply for an Impact 2020 grant through the North Central Region Water Network. And we were honored to receive that, and I, along with Christina Curell and Paul Gross, are the leads on that project. So the team has several long-term goals, and I'm going to paraphrase here because our goals are really long when you read through our proposal. But essentially, our goal is to help land-grant university personnel be better able to implement practices that improve soil health and water quality by gathering resources related to soil health, including curriculums, research protocols, and publications, and by creating a permanent group that can continue to collaborate about soil health and water quality issues into the future. Somebody is very determined. This capacity will allow us to have the basis to continue to apply for grants and to work with people outside of land-grant universities to sustain healthy soils and to protect water resources. just ignore the phone ringing. As part of the proposal process for the Impact 2020 grant, the team developed a concept map to guide the project, and out of that concept map, 4 primary short-term goals came to light. And I'll go through those goals here. The first one is to discover what barriers farmers face when considering adoption of soil health practices to improve water quality. We want to know why farmers are choosing to or choosing not to adopt those practices. And we'll be doing this with a survey of farmers, agribusinesses, extension personnel, as well as agency folks. And those survey results will then feed into other goals, helping them to make decisions on how best to attain their goal as part of the project. Oops. The second goal of the project is to compile a toolbox full of resources, including but not limited to publications, curriculums, demonstrations, videos, maybe photos and blog posts. We want to put those all in one central location where if you are in need of something for soil health, you can go to one place. And I'm going to show you that in just a bit. It'll be our Soil Health Nexus website. The third primary goal of the team was to facilitate professional development opportunities for educators and researchers that are working in that soil health and water quality areas. And so the second and third goal really fit well together in that the toolbox will feed into that professional development, and then vice versa. Those professional development curriculums will also be placed then back into that toolbox so we can continue to come full circle with this thing. The fourth goal is to develop protocols for doing on-farm research. Researchers from across the region are teaming up with extension specialists as well as educators to develop proper methods that can be used by farmers or educators to determine whether a particular strategy is going to work on their farm. And so those things will also feed back into that toolbox and be available on the website. So I mentioned before that there's going to be one location to access all of these resources that I described. And this started with that original Soil Health Nexus team and is continuing to evolve. It is a work in progress, as we do expect that the resources are going to continually be added to this website. But it is available at the soilhealthnexus.org. And currently the reports and data briefs from the 3 projects that you heard about today are already on that resources page. You just go to soilhealthnexus.org and you click on this resources link. And so I encourage you to take time to check them out and go find out more about the projects that we talked about today. So with that, I'll turn it back over to Rebecca, and I think we can answer your questions.
Excellent, thank you. And you could, if you haven't already, Leslie, you could put the URL in the chat box too for folks, just so they can click on it and get to it right there. So here we are at our question and answer session, and we had no questions submitted in the chat box. So feel free to do that now if you have a question and just haven't put it there, or that would be easiest actually if you would do that rather than saying it out loud. So questions for our presenters, and even if our questions have if our presenters have questions of each other, you can feel free to fill in there too. Well, so I have a question, then I'll fill in. I have a question about tracking environmental changes after policy changes for Jason and or Steve. I was wondering if you had thought about in your research who might be the right entity to do that, or have you seen interest expressed in doing that from anyone?
This is Jason. I think that's a very interesting question. My fear is that when we're talking about this type of data, we're talking about the need of individuals to have been tracking environmental impacts for a long time prior to this, so that we can get the before and after effect. it's very possible that this data is already out there, somebody's aggregating it, and we just have yet to see it in the literature. As for who that individual would be, I frankly don't have any great insight on that particular area.
This is Steve. I do think, though, that we could run the potential issue of using that data for regulation. So I would definitely recommend that be done by an extension organization and university as compared to the state, because I think that might alleviate some of the concerns that the data would be used to actually set more rules before we even know the solution. So I think it has to be very long-term data collection to make sure that we're really finding the true trends.
Great, thank you. I had another question for Amy and Linda, and one of your slides, perhaps I should know this, but one of your slides talked about having nutrient application be balanced on an annual or multi-year basis. I think that was in your recommendations. And when you say balanced, what does that mean?
Yeah, that's a good question. What I had intended for that is, so oftentimes manure that's been applied at a nitrogen rate for crop production over applies phosphorus. And then when you're comparing in that same study and they're comparing to inorganic fertilizer application, they might apply the same amount of nitrogen, but they would not balance the amount of phosphorus and potassium that the manure is applying to the crop. And so it's not apples to apples, or maybe they're applying a certain rate of manure and then just applying inorganic fertilizer for the crop rate, but the manure is providing less nitrogen than what the crop actually needs for that year. And so just to make sure that those nutrients applied in those field studies are the same. So the same amount of nitrogen is applied to the plots, or the same amount of phosphorus and potassium.
Thank you, Linda. That's helpful. And we have a question for Tang about water stable aggregates and how water stable aggregates are normally measured. Tang, are you unmuted?
Can you hear me now?
Yes.
Okay, sorry, I rejoined and somehow the audio wasn't working right. So to be honest, I don't know or see how the water stable aggregate or the other variables that we use, how they were actually measured in the lab. So I believe Donna Brandt, who represents the University of Missouri Soil Health, it's online here. So if she has the mic, maybe she wants to jump in to say that. So I'm not a soil scientist. I can try to answer that, but I think it's going to be too dangerous for me to say anything that could just misguide you. Donna, are you on?
Janice, can Donna speak? And Donna, if you can't, you just may want to make sure your microphone is unmuted, or you're in the. There should be a place for that in the lower portion of your screen.
Yep, you should be able to just unmute your microphone and speak.
Now?
Yes, we can hear you.
Oh, okay. All right, so the aggregate stability was measured by, we took aggregates between 1 and 2 millimeters in size, and we put them on 0.5 millimeter sieves and submerged them overnight, and the next day raised and lowered the sieves 20 times in 40 seconds, and then weighed them out to see what portion remained on the sieves. Does that answer the question?
I think so. Yep, we got a yes. Great.
Okay. Good.
And
Thank you.
Thank you. And Gary had asked who or which land-grant university will be managing the Nexus website, and Leslie generously answered in the chat, but I'm sharing this orally, so it's available on the recording, that the North Central Region Water Network and University of Wisconsin Extension currently administer that site, but as Leslie says, multiple land-grant universities have access to and can update it. So it's a team effort. Okay, any other questions for our presenters before we move to our next topics? Okay, so our next topics are on March 14th, we'll be talking about evaluation and outreach programs, topic and trends. And actually, that April session is going to be something a little bit different. So we're looking at that soil health needs assessment presentation probably in June. But for the evaluation presentations, our own Amber Mace will be presenting, and actually on something related to this, which is an evaluation of Wisconsin's runoff risk advisory system. And Scott Chasden from the University of Minnesota will be speaking about ripple effects mapping as a method for tracking the impacts of outreach-related initiatives. So thank you so much, everyone. Thanks for hanging with us with some of those technical difficulties. And the recordings are available at North Central Water, or will be available in a week or so at northcentralwater.org or learn.eextension.org. And you will be able to see all the slides on those recordings. So thank you so much and have a great afternoon.